Python 101. I'm Paul Bailey. If you ever want to follow me or ask me any questions, you can send me any direct messages on Twitter. I'm Pizza Panther. I'm trying out this thing called Slido, or Slido, I don't know, .com. I made a room called Pi101. So if you go to that and you have any questions, I have my laptop down here. You can raise your hand too, but if you just want to submit any questions, I'm going to try and watch that as we go along. And if you all want to, you can vote up and vote down questions too. So, and you can submit stuff anonymously. So that's what's nice about it. So a little bit before we start it, like I said, I'm Paul Bailey. I'm a front-end engineer actually right now, although I have a background in Python for like the last 10 years or so. I work with a company called Learn with Homer. We do apps to help kids read and do math, and little kids, so like preschool, kindergarten age. I also created an IDE called NeutronDrive.com, and I'm the web chair of this conference. So if you don't like the website, you can go complain to someone else. Don't tell me about it. And yeah, I'm basically obsessed with anything web-related, so I do a lot of Python programming in terms of the web, anything with the web, JavaScript, Python. I love to do it. We also have Chris here in the front corner. If you have any questions, he can help you. I'm going to try to keep this, redo some hands-on coding too. So when we're in that part of the talk, so we have 2 sessions here. The morning will be more talk, but you also do a little bit of hands-on. And in the afternoon, I have a site that has a bunch of like exercises. Hopefully we'll get through most of the talking by then, and then you can go through and start trying some of the skills that you learned today out. I always think for programming, if you really want to learn it, you got to actually do it. So I can talk all day, and until you actually go do it, you're not going to understand it fully. So, you know, we'll hopefully keep this a lot of interactive as I go through, and then in the afternoon, maybe finish up the talk part of it and just do some projects. And, you know, come and go as you please. I'm going to try and take some breaks, since 3 hours is a long time for a session. So I'm going to try and time it here. We'll take a break maybe every hour or so. All right, so like I said, we're going to be using coding.com. That's what I'm going to use to showcase all these examples. And I'm going to use Python 3. So if you're new to this, probably Python 2 is what's used a lot right now. But we're to the point now where Python 3 is ready and people are starting or have already started converting stuff. So as a beginner, Python 3 is a lot easier to learn. It doesn't have some of the warts that Python 2 has. And so, but they are still pretty close. So if you ever need to go back and do Python 2, you should be fine. But we're going to do Python 3. So is everyone signed into coding and have some kind of Python environment ready before we continue? So if you don't have it, I would just recommend go to this coding.com. It'll take you 2 minutes to sign up, and they have Python 3 installed ready for you to go. So we'll just wait a few minutes here, make sure everyone's on the same page. And this is what coding.com looks like once you get in. So let me know when you get to that point. And if you have a GitHub account, I think they have a GitHub and a Google login and Facebook login too, probably. So you can just sign in. And everyone got their internet connected? Any problems with that? You got your internet connected? Okay. The internet's pretty good here, but it is a little confusing first time you get on. All right, so just to kind of go over this coding environment, what coding.com gives you is you get a workspace that's out in the cloud. So you're actually getting a virtual machine. It's a Linux virtual machine, Ubuntu, I believe. And you can see you get a free workspace here. So this is your virtual machine. If you come back later on in the talk, if you've inactive, it will actually shut down your machine, and you just turn it back on. It will log you back in. And then on that virtual machine, you can see here in the corner, let me go ahead and get rid of this column. So you can see by default, they have some files here that they put on there. Let me go ahead and go into this web, because there's actually a Python file. And you can see, I'm going to drag up this at the top here. So this is how I'll showcase a lot of stuff. Actually, right now, I'm not going to showcase too many Python files. If you have, we're mainly going to work in a terminal right now. So if you click this little plus button, you can do a new session. So let's go ahead and let me get rid of this. I'm going to make my session a full session here. And so this is a command prompt. If you're not used to this, I'm just going to go over a little bit of the Linux commands. We could probably have like a 3-day class on just a command prompt, but just to kind of give you a little, quick beginner course of the command prompt. If you type in ls and then enter, that lists the files that are in that directory. If you type pwd, and is this big enough? Can everyone see that? If you type pwd, that tells you where you're at, and you can see right here, these files that I listed are the same that are listed over here. CD lets you change directories. So you can see these blue things are directories. So if I want to go into that directory, there's nothing in documents. And then if I want to go back, you can do cd ... So let me go into the web one. And so that's just listing out your directories. Cool little tricks when you're on the command line, and some of these will actually work in the Python interactive shell that we're going to go to in a second. So if you see a file here and you want it to list it out, you can start typing it and hit tab. And if you hit tab twice, it's going to give you all the matches. If I keep on typing here, you can see and hit tab again. Okay, this isn't. Tab completes whatever you're able to, let me do it this way. There we go. Tab will auto-complete for you. Now, if there's too many matches, you can hit it twice, and you can see all the matches that it will do. But that will save you a lot of time in having to type stuff if you hit tab. It also keeps a history of all your commands. So if you hit Control-R, that actually does a search. And then you can just hit Enter. And that will, if you want to redo a command that you previously typed, you don't want to type it out again, that's a cool little trick. All right. So like I said, we're using Python 3, so let's go ahead and type in, you want to follow along now, type in Python 3 on your terminal. And this is going to start what's called the Python interactive command line. So, but before we go into that, you can leave that up and running. Let's talk about a little bit about what is programming. So, a computer basically stores and manipulates information. And a program is just like a set of instructions for manipulating or telling a computer what to do with that information. So some examples of programs, maybe you have a dynamic website where someone clicks on a button and it goes purchases something. Think of Amazon. Process video, process audio, send an email, that's a program. So all these things, when the computer is actually doing something or manipulating information, that's what a program is. So another question you'll probably get asked a lot of times is, okay, well, why am I using Python? Or why did you pick Python? So Python is really at heart was made to be a teaching language, something that you can teach in a computer science class to give you all of the principles. So it's a good language to learn. It's really readable. Now that it's been around so long, it's really powerful. So, if you're doing web development, if you're doing machine learning, has a lot of different uses. Some languages, have a more narrow focus of what they're good for. Python is a very good general purpose language. Awesome community, as you can see at PyTexas here. Interactive shell, which we started already. So, and we're going to play with that a lot here. So we can jump into the interactive shell in order to test things out before we actually write a program, which is really useful. And yeah, like I said before, it's got a really rich community. It's got a really rich ecosystem of modules that people write. So for almost anything you want to do, there's probably a Python module out there that will do it for you. And towards the end of the talk, I'll show you of how we can use those third-party modules. All right, so we started this already. And if you haven't, go ahead and start up your Python 3 interactive prompt here. So first thing we're going to do is just do general arithmetic. So we're going to use Python as a calculator. And there are a bunch of operators in Python. So there's plus, there's minus, multiplication is the asterisk. There's division, there's the modulo. So let me go ahead and I'm going to get out of here for 1 second, clear my screen. All right, there we go. All right, so let's just start testing some of this out. And in your interactive environment, you can follow along and try some of these commands out. So yeah, 5 plus 5, right? This is pretty easy. There you go, you have 10. Let's do some multiplication. So we do 5 times 5, 25. Let's do some division. 12 divided by 3 gives you 4. I mentioned the modulo. So this is kind of an interesting mathematical operator that a lot of times you maybe don't think about. It gives you the remainder. So if we do 10 divided by 3, we get 3.333. But let's say we wanted the remainder of that. You can do 10% 3. So that gives you the remainder if you just wanted that piece of that. So you can use the interactive shell as a calculator. So the main takeaway with this is that there's operators in Python. Plus, minus. I guess we didn't do a minus example. Let's do a minus example. There you go. 5 minus 10 is negative 5. Yes. So that's one difference that you'll see between 2. You would have gotten an integer with Python 2 for that one. Python 3 is smart enough to know that if you 10 divided by 3, you actually want a decimal number, not an integer number. So, all right, so that's just some general arithmetic. We did division. And these slides are linked to the talk on the website. So if you want these slides, print them out and go through them. You can get that link there. Or if you want to use them now. So we did some division. All right, so let's go over some comparison operators. Again, these are just mathematical things. We're going back to math here in Algebra 1. So you can also do like 1 is less than 10. That's true. But is 1 greater than 10? That's false. If you want to do an equals, so 10, let's do 10 equals 10, you need to do, the operator is actually a double equals. So 10 equals 10 is true. 10 equals 11, that's false. And then we can combine some things, so that's less than or equal to, or you could do greater than or equal to. And so these are all of the comparison operators in Python. And we just went through that. Let's go ahead and, I guess, let's combine these a little bit. So we can combine some things here. Now again, we're going to go back to math class here. Python will follow the order of operations if you go back to your math teachings in high school or college. So if you want to get advanced with this and have certain things happen first, you need to use parentheses. Now this is probably going to fail. No, it worked, okay. So like that is going to be different than this. Because whatever's in parentheses is going to get calculated first. So if you're getting a little confused of what's going first, you don't remember your order of operations from back in Algebra 1 or whatever, whenever they teach that, you know, you can put some parentheses around stuff and have that execute first. And we can get real advanced. We can combine a bunch of things here, get real advanced with our math. So like I said, depending on if we put parentheses in different, if we don't use any parentheses, it's going to follow the order of operations, where this, now I've changed that order by using parentheses. All right. So basically, we used Python as a calculator so far. Now, there are different data types. Right now, we've just been using math. So we've seen different data types. So far, we've seen 2. We've seen integers. So that's a number without any decimals. And then we've seen what's called a float. So that's a number that has a decimal after it, and that has a certain precision to it. But there's other data types that we're going to get into here. There's strings. So string is just basically a list of characters. So a string would be like, hello world. And for strings, you can use a single quote or you can use a double quote. We're going to do a lot of strings. Actually, we've seen some Booleans already. Booleans just mean it's a true or false value. We're going to go over lists. So lists are a collection of things that are in an order. And then we're going to go over dictionaries. Dictionaries are really powerful. Dictionaries is a list of things that are where you can look up things by a key. So if you think of a real dictionary, you have a word, you go look it up, and you get some definition, or in our case, you get a value of some sort when you look that thing up. So in Python, if you have something and you know what its type is, there's a built-in function called type that will tell you what it is. So you can see 5 is an int, but if I do 5.0, that's a float. And let's do a string here. You can see that will tell us whether it's a string. That's the string. All right, so let's go into strings a little bit here. So like I said, you can use double quotes, you can use single quotes, up to you. Let's clear that out. So we have a string here called apple. But now if we type apple without any quotes, that's going to give us an error. Without any quotes is actually a variable. And we're going to get into that very soon here. But if it's a string, you want to put quotes around it. Pretty simple so far. All right. So now, the nice thing about strings is that some of the operators that we just learned for math, we can also apply now to strings. Not everything, but certain things. And the same will be true for the other data types that I listed. Some of these simple mathematical operators will work on the other data types. So if we take hello and we add world, all right, so who thinks they can guess what's going to happen? Yeah, it's going to cat them together, or it's going to add them together. Now you can see, because I didn't have any space, it's just pushing them together. Here's another one we can do. So hello times 5. This will multiply it times 5. So we're going to get hello 5 times. Okay, so let's try this out, though. What if we did hello times world? That gives us an error. So when you multiply a string by another string, what's that supposed to do? There's no real intuitive thing that should happen there. So that operator does not work with a string and another string. But if you do a string times a number, the guys who wrote Python said, hey, you know what? This should just multiply it 5 times. So that's built in. So that's some of the operators for strings. So now you can think of a string as a set of characters. So if we wanted to pull out just 1 or 2 of these characters, let's say. So we have hello. And your index always starts at 0. So whether we're talking about strings or lists, in this example with hello, H is index 0. So if we wanted to pull out just the H, we can do the brackets, square brackets, and a 0. And that will pull out just the H for us. If we wanted to pull out just the E, that is index 1, and so forth. Now, another cool thing that you can do is you can actually do negative indexes. So if you do a negative index, that will give you counting from the back of the string. So that's going to give us the last letter. Gives us the O. If we do -2, There you go. You get the second to last letter. Pretty easy and pretty cool. Because minus 0 would just be 0. So unfortunately, it is a little like inconsistent, but yeah, you just have to think about it. You can't really have negative 0. So yeah, from the beginning it starts with 0. From the end it starts with negative 1. So yeah, that's a great question. So one of the other things you can do, so let's say you want more than one letter. You want what we call a slice. So let's say you wanted the first 2 letters. We want to start at index 0, and we want the first 2 letters. You can do a colon and then the ending. So that will just give us that slice of that string. So it actually counts. Yeah. So that is a little confusing. Is that first one's the index, and the last one is kind of like the length. Yeah, exactly. Kind of like. Well, it's not necessarily the length because you just have to think of that as minus 1. Yeah. So it's not really the length. It's just that you have to think of 0 to n minus 1. So now Python knows what you mean if you don't put a number in there. So if you don't put any number for that first one, it knows you mean 0. So that will give us the same thing. Same thing, let's switch this up a little bit. If you don't put anything in the last one, it knows to do everything till the end. So this one will go from index 2 to the end. And we could put our negative indexes in there too. So that gives you slices of a string. Any other questions on that? All right. Now, right now, since we're in the interactive editor, oops. You want to start from 3? Oh, well, so that, if you did like that, yeah, if you did this, that wouldn't work. Well, it gives you empty, so you're not getting anything. If you did 1, I guess that's empty too. I don't think I've ever tried that before. Yeah, so it's not really the length. It's not really the length. It's really index plus 1. So it's not taking that last index. It's taking everything less than it. So I guess that's probably the better way to say it. It's everything less than that number. Every index less than that number. Yeah, so it's not really a length.
Okay, so 2 colon minus 1.
Yeah, so it's really like, so when we do 2, 3, it's really saying any character from index 2, like this, less than or equal to 2, or less than 3. So it's not taking that last index. It's starting at index 2 and then doing everything less than 3. So far, when we type a string or when we type in the interactive terminal, because it is interactive, it just kind of spits it out and shows us what it is. When we go right into a program, we actually want to like output to the screen. So if you're in a program, if you're writing like a Python file and you just do hello, it's not going to just spit that out to screen. It's just going to run through it. So if you want to actually spit something out to the screen, you have to use the print command. And the print command is pretty easy, pretty flexible. You just give it something, and it prints it. Now, since we're in an interactive terminal, you can see it's very similar to what we've been getting. But you can see, if you compare it to the top where I just typed hello, it doesn't have the quotes around it now. It's only printing out what would actually go to the screen. So we can give this all different kinds of types. So if we give it a 3, it's going to print a 3. If we want to print multiple things, so we can do like this. Now, before, when we just added things, it didn't have that space in there. Print is smarter and knows if you want to print out the screen and you give it multiple things, it knows to put a space in between it. Or we can add a number in there. Let's add a number in there. Now you can actually change the way that spacing works. I'm not going to get into that. You can actually say, okay, put a dash in between things, or so you can actually customize that command. But for right now, we're just going to do spaces in between everything. And like I said, anytime you want to print stuff to the screens, this is how we're going to do it, since this is just a beginner's class. Now, in a different, if you're doing like web programming, you're basically printing back out to your web browser. So you're printing back out through your web server. So this is very powerful. And in the coding environment, you can see if you did open that Python file, it's just doing print commands. And all that stuff that normally would go out to your screen instead is getting piped out to your web browser. And so if what would go out to a web browser might look something like that, with some HTML in it. So print is actually really powerful. And yeah, we went over that. So you can print multiple things. We can do some math in there. I guess let's put some math in there. It'll do the math first. Again, going back to order of operations. It'll do the math first and then print a result. All right. So that's print. We're gonna use print throughout the tutorial here. All right. So let's go on to variables. All right. So what we've been doing so far, we just kind of been playing around in the command line environment. But when you write a program, maybe you're going to do some math. You actually want to store this somewhere. Maybe you're going to manipulate a string. You want to store this information somewhere so that you can reuse it again. So anytime you want to store something, we can just make up a name for that variable. And let's do 12 times 12. Now you can see this time it did not output the answer to our interactive terminal because it stored it in that variable. The thing to point out here is this equals does not mean what you would normally think in math. It's an operator that says, take whatever happened over here and assign it to this value. So if I take answer, you can see it's 144. But if I were to do this again, this is not saying answer equals that. It's saying take 12 times 13 and store it in this value, this variable. So you can see answer now is 12 times 13. So this is really, when you're programming, this is considered the assignment operator. You're assigning a value to that variable. And it always goes from right to left. So whatever happens on the right is getting stored on the left. So in Python, in some programming languages, it wouldn't let you do what I just did. It would say, hey, or actually it might not let you do this either. It would say, hey, this is already an integer. You can't make this a string. So Python, you can just overwrite it. So I can keep on overwriting this value to kingdom come, just filling it in. I actually don't have this in the slides, but there's a none type. So you could do that too. So you could say answer equals none. So now it's just empty. But there would still be a variable in your namespace. There is a command. I guess we could use that. I don't know it off the top of my head, actually, for Python 3, where you could delete that if you just wanted it totally out of your namespace. But most of the time, it's just a matter of you just want to overwrite it. So you just put whatever the new value is in there. Yeah. So you can see now answer now is none, so it's empty. But then if we go set it back to 12 again, it's now 12. So normally you're just overwriting it. I guess one thing, since that I didn't talk about, since Python is a higher level language, it does what's called garbage collection. So, and we'll get to this further in the tutorial, when you start writing functions and classes, once you're no longer using that function, or once you're no longer using that class, and let's say you had answer in your function, Python knows to say, hey, he's not using that variable anymore. I'm going to go clean it up. And that will no longer take up your memory. So like in C, you would have to go manually say okay, I'm not using this anymore. So I want to save some memory, go delete it out of my memory. With Python, you don't have to worry about that since it's a higher level language. So there are trade-offs. It's easier on you, but now since Python is doing garbage collection, it has to, use more memory and take up some processing power. So yeah, that actually, your question was great because that was the next thing, is if you want to assign a new value, you can just keep on reusing that variable over and over again and assign things to it. And again, like we said, you can assign new things to the variable. You can assign a string, you can assign an integer. It's not going to matter. So let's go into, let's say you have a string. So let's go back and say you got some input from the user, and it's a string. And we can see answer is a string. But we really want to do some math on that. We can now convert that to an integer, let's say. So if you want to convert stuff to different types, there are built-in commands. So int, we'll change it to an integer. So let's go ahead and store that. Again, we have to reassign it back to answer. So int is producing an output. If we want it to be back an answer now, you have to store it there. So you can see now answer is an integer. Or if we wanted to go the other way around, and now put answer back to a string, now answer is a string again. So there are several built-in commands that will convert stuff back and forth for you. Some of it's built in. When we get to some of the more advanced data types, it's not necessarily built in, because let's say you take a dictionary, which has like all these values and keys and stuff. What does that mean when it's a string? You know, there's not an intuitive answer to that. So, but for integers and strings, you can, or floats, let's go ahead and convert that to a float. And we can see that that now has a decimal on it. So that's how you change between different types. Between what? Answers? The quote, one with the quotes, or which one? So originally I started off with answer equals 12, right? So right now it's a string. So now let's say I want to convert that to an integer. If I did answers without the quote, yeah, then. So if I did that, it's an integer already. Yeah. So I'm just showing that you can convert stuff. You know. Yeah. But it depends. You know, it depends how you're getting your input. So, you know, if we're just asking for people to type in stuff on the command line, which actually we're going to get to here soon, anything that you just like type in, it considers that a string.
So with this quotes, it's taking it as an Asachi 12 without saying it as an integer 12.
Yeah, yeah. So if you put the quotes, it's going to make it a string for you. Yeah. Or if you don't put the quotes, it knows 12 is an integer. So a lot of our input, when we get to input here, a little bit on in the tutorial, when you're typing in stuff, that's a string. And so you have to convert it. Or like to go back to web programming, if you fill out a form on a website and you're typing stuff in, and that comes through your web server, all that's strings. And so now if you're doing math with something, you have to convert it to an integer if you want to do math with it. Yeah. So, yes. All right, so let's do one more cool thing with strings here before we finish off on strings. So we've done adding strings together, which cats them together. We showed print, which will kind of put spaces in between and output of the screen. But you can also do what's called string formatting. Sometimes if you're doing something like this, and let's say we have like 5 or 6 things, this gets tedious sometimes if you're trying to add stuff together. And then let's say we have our answer in the middle here. When you start getting, I guess let me change answer to a string again. When you start adding a lot of strings together, that can kind of be tedious. So in Python, we have what's called string formatting. And this is going to be one of those things. Python 2 has this, but Python 2 actually has an additional different string formatting too. But this is the new Python 3 version. So we can do hello world. And then we can say the answer is the curly brackets is where we're going to fill in our answer. And then we can say format. And we can say answer. So if I hit enter here, and if you want to try this out on your command line, it takes where we put the curly brackets, sticks it in there. If we wanted to stick it somewhere else now, We can stick it in the middle of the string. Now, right now, because I converted it, answer is a string. But format, it's smart enough that I'm going to set answer to an integer now. And if I go ahead and do the same thing, format is smart enough to know, convert everything to a string automatically for me and stick it in there. So this gets even cooler. Let's say we have multiple things now. I guess let's do the cat. Let's do the cat example. All right, so my cat's name is Neutron. Oops. And the number of pets I have 2 cats. And then I want to say, hello, my cat's name is, and I have 2 of them. So I can also, just like print, put multiple things in here. And it will fill them in for me and convert them automatically. So you can see name was a string, number of pets was an integer. It automatically converted what needed to be converted and stuck it in as a string for me. All right, so now this can get even cooler though now. So say I wanted to use name multiple times. So let's say I wanted to stick it at the end here. So I could do this. So again, it sticks it at the end. Or I can name my parameters. So I can put numpets. And I can put name. Now I have to use what's called keyword parameters, and we're going to get to this later on. Instead of just passing it in, I have to say name equals name, and the number of pets equals the number of pets. Now, what did I do wrong here? Did I get my own syntax wrong here? Tuple index out of, oh, that's why. I forgot to fill in this one. If I spell it right. So everywhere it says, you see curly bracket name, and everywhere it says, sees curly bracket numpets, it's going to fill it in for me. So now I can use that variable multiple times without having to specify it multiple times at the end. So that's what's called string formatting. And that's actually really cool when you start manipulating stuff and then you want it to output and have it fill in. You know, you can kind of think of this as like a mini templating language. You know, fill in spots with stuff that you've done. Any questions on that? So let's go back and do 2.0. And then we'll rerun that. Now, Python 3 is pretty smart about putting the decimal points in. You know, if we did this in Python 2, you'd probably get like 0, 0, 0, 0. Python 3 is a little bit smarter with floats and integers. So I guess maybe a good and better example would be, let's do 10 divided by 3. You can actually, so you can see all those decimal points. There's actually ways of formatting numbers too. I'm not going to go into that, but you can tell the string formatting how many decimal points you want, and then it will cut that off for you. So there's a syntax for that too. So if you just wanted to say 3.3, no matter what, you can do that. All right, so that's string formatting. And so I just want to kind of mention errors here. And you've seen these. Oops, wrong one. You've seen these as I've gone along here. As I've done stuff. Oops, wrong way. All right, let's just clear this because I'm not getting that right. Let's create an error here. So as I've gone along, you've seen these errors. This is a Python error, an exception. Let me go through my slides here. So anytime you do something that Python doesn't like or that causes an error, you can throw what's called an exception. I'm not going to go over this other than that. If you have these in your program's going to stop. You'll see this stack trace, what's called a trace back. This is kind of one of the things, that just takes time to learn. But as your programs get more advanced, it will show you, the trace of your code and go through your code and show you where the error is. Since we're on an interactive terminal, there's not too much to basically see in terms of code since it's right there. But you'll start to notice some of the typical errors. So like type error means you took one kind of type, we took a different kind of type, and we tried to do something with them, and it didn't know what to do with it. So that's a type error. Some of the other, I guess, standard errors. Actually, this is an error here. If I just hit Control-C, keyboard interrupt. So that means, like, if you have a program running and someone hits Control-C, you'll get a keyboard interrupt error. You'll see that as an error. So that means the person basically killed your program. Some other common errors are like value error. And we'll see these as we go along. And, basically, it just takes some time to kind of learn what these different errors are. All right, so we're going to go ahead and take a break. So if you got to use the bathroom, this is the time. And when you come back, I have some exercises here that you can try on your terminal or on your computer. And we'll review them. Let's say, I think 25 minutes, 30, sounds good? Come back in 25 minutes. So at 10:30, we'll review these. And if you want to ask some of us for help, you don't have to do all these, but if you want to pick one and try it out, we'll help you try and get that running on your machine. And so at 10:30, we'll come back and go on to the next part. All right, so the second exercise. Calculate how many seconds all the attendees will spend at this workshop. So, what did I do? Okay, so there's 2 sessions. They're each 3 hours. So 2 times 3. And then, so I put some parentheses. I don't really need them for this, but just kind of to separate things, to keep it organized in my head. There's 60 seconds in a minute, and then there's 60 minutes in an hour. So that's what the 60 times 60 is. And I just said there's maybe 22 people here. That's why I put that in red. And again, the last part of this, we could have done several different ways. but in this particular, on the slide, I just use print. So that's the number of seconds to attendees. Let's go ahead and we'll go ahead and run that one. So that's how many seconds we got. And then let me go ahead and copy and paste that. Oh, I guess I didn't like that copy and paste. So let's just do this ourselves, I guess. I'll have to do this in pieces. And then copy the last part of that. So there you go. Got it. If there was 22 of us, that's how many seconds we would have used up in this class today. All right, so the last exercise, calculate the number of donuts made in a week if 15 dozen are made. I guess we probably should have done kolaches since we have kolaches here. And so again, 15 dozen, so there's 12 in a dozen, 7 days in a week, and then we're just printing that out again. And then we can see we're just doing some math right in the print statement, but we also could have put that here if we wanted to. So that's just your preference on that exercise. Okay. Anyone have any questions on the exercises? So plus is just concatenation, so it's just adding things together. Again, that's just another way you could do it. It's really up to you in your programming. Well, with print, the comma will put a space in there for you. So, it's just whenever you're writing a program, sometimes it's going to be more compact to use a plus. Sometimes it's going to be better to use string formatting. So just whatever makes sense for that program. There's several different ways to do that. All right, so we're going to go on to our next data type here, which is lists. So, if you just think of a list in general terms in life, right? You might make like a shopping list. So you put apples, bananas, milk. So a list is just a collection of things in an order. And so in Python, we have a data type that's called a list, and it's pretty easy. So let's go ahead. Again, if you missed that, whenever I'm clearing the screen, I'm just hitting Control-L. So, and a list is the square bracket. And then, so if we want a list of our fruits, let's say we're making a shopping list. Get some apples. Let's get some milk. I guess we want some donuts since we talked about donuts earlier. And then we can see if we type in fruits here, there's our list of things. We can make a list. It doesn't necessarily have to be strings. It can be a list of anything. So we can have a list of numbers. Let's try that out. So let's say we had some answers. So now, there we go. We have a list of numbers. And you can see actually in that one I mixed integers and a float. We can put anything in that list we want. We can mix different types of things in that list. All right, and again, if we ever want to figure out what the type of something is, you can see the type of that is a list. So it's just a sequence of things. Now again, going back to our operators that we started with, our numeric operators, some of these operators that we did with just simple math will work for a list. So there we go. We just doubled the amount of items in our list by using the times operator. Or let's do this. Same thing. We can use the plus operator. We just added a bunch of lists together. Actually, let's make this a little bit more interesting. Let's put our answers and our fruits together. So now we took our answers, added fruits to it. So a lot of these operators, mathematical operators, work the same way with the list type as they did with our string and our integer and float types. Now, let's get a little bit cooler here. With strings, we were able to say, give an index and have, pick out one or two things. We could slice it or we could just index it. So we can do the same thing with lists. So if we have our fruits, we're going to know what the first fruit is. Same syntax as we use with a string. Our first fruit was an apple. We can do slices just like strings now. So let's take the first two things. So now that gives us a slice of that. And then if we wanted to store that, we could say first fruits. And now is that slice. We can store that. So just like we manipulated strings and used operators with strings and integers, we have the same kind of manipulation we can do with lists. It's a really powerful data type. Let's try it out. So let's take our fruits and our first fruits. And you can see that particular operator isn't supported. Now, with that said, there are ways to do that. I'm just not going to go into that are built in.
That's trying to do it as a mathematical
Yeah.
logic. There's no numerical
Yeah.
representation.
So, that's not really like an intuitive operation of what should happen. So that's not like in there by default. There are actually other methods, other functions that will do that for you. So I'm just not going to go into that. Yes, I mean, if you wanted the data type of that first item, you could just pull that first item out and say that's a string. Now, there are more advanced data types. The list is a standard data type that comes into Python. You could make a data type that enforces, that says, like, I only want a list of strings, or I only want a list of integers. But that's, a more advanced data type. You can actually take any of these data types. Now, I believe there's actually already a standard data type for that you can use. But let's say there wasn't. You can actually take any of these data types, and we'll get into more object-oriented stuff a little bit. But you could take any of these data types and add some of your own enforcement logic, and make your own data types if you wanted to. So this is just a standard Python one that you'll probably use lists a lot, whenever you want to collect things. And so, yeah, we showed off the slices. We showed off if you want to index. Actually, I forgot to update this for Python 3, so let's update that now. We showed that off. All right. So, if you want some more exercises when you go home, there's actually other data types that are built in that are very similar to lists, but are a little bit different. So, when you go home and you want to review some more stuff, look at tuples and sets. I'm not going to go into that because they're so close to lists. We can do everything we want in this session, but there are more data types that are really similar and give you different, methods and different things that you can do with them. So, like real quick, like a set, like with a regular list, you can see that I can have the same things over and over again, so I can have duplicates. Or like with a set, it will actually make sure you don't have any duplicates. But you can review that at home. Everything we're going to do is going to be with lists. So dictionaries. We talked about dictionaries. Dictionaries are another, higher level data type, but really powerful. So, just like a regular dictionary, you want to look up the definition of word. So you get the word. In our case, this is going to be what's called the key. And then you get the definition. So in Python, that's going to be, or in programming, that's going to be considered the value. So you'll have keys, and then you'll have values. So in the dictionary, what do they use for our example? Okay, we'll do pet counts. So let's say I want to keep track of all the different amount of pets I have. And I want to say I have 5 cats and I have 2 dogs. So there would be our dictionary. So the key in this case, or what we're using to look up the value, is cats or dogs. And then the value is whatever's associated with that. So this works really similar to what you've seen now. So now we have this dictionary. And let's say we want to know, okay, well, how many cats do I have? Just like we use the index with a list or a string, our index now, instead of being a number, is that string. Or in this case with the dictionary, it's not really an index, it's what we call a key. So we have the key, which is cats. We have the value, which is 5. So some other things that you can do with a dictionary. So we'll have a list of things that are in this dictionary. Let's say we wanted to know all the different pets, all the different keys. We wanted to see if I have any dogs. So one of the methods on a dictionary is keys, and that will tell you all the different keys you have in that dictionary. And we're going to go into this a little bit further. But if you wanted to check do I have any cats in my cat dictionary, pet count dictionary? Yes, I do. Do I have any dolphins? So the in keyword will basically go through those keys and check to see whether you have a key that's that. You have a question?
So everything that you can put into your list ends up in the dictionary and then it'll pull it out, or it doesn't pull just anything random?
Yeah, so if I put in, let me go back here. If I put in dogs, it's now pulling that dog's value out. Let's say I did try dolphins. I never put that in as a value. You can see I'm going to get an error because I never entered that into my dictionary. So with dictionaries, you're not guaranteed an order. So with a list, you're guaranteed an order, whatever you put them in as. With a dictionary, it's just key values. So if you're iterating through your keys, you're not necessarily going to get them out in the same order that you put them in, because you're looking stuff up by a key and not necessarily an order of how you put it in. So let's say I did want to put in a dolphin now. I can add a dolphin now to my group. So I have an existing dictionary. I can say, okay, now I'm saying I have 3 dolphins. So let's check out our keys now. And you can see, there we go. I have dolphins in my dictionary now. Now, normally, you'll see it start coming out as in the same order, but you're not guaranteed that that's going to happen all the time. So, again, there are more advanced data types. There's actually an ordered dictionary in Python, if that's something that you need. So the way an ordered dictionary will work, the order that you put them in, you'll get them out in the same order. There's a cost to that, though, because it has to keep things in the order. That takes up more memory, more CPU. So normally, if you're using a dictionary, it doesn't matter what the order is. So this is a great data type if you just want to store stuff with a key and a value. Any other questions on dictionaries? Again, a really powerful data type in Python. In other languages, they might call them like hashed arrays. It's the same thing. Or sometimes they're called a map. So like JavaScript really doesn't have a dictionary, but you can have a map object that basically gives you the same thing as this. All right, so let's go on to the next data type, Booleans. Again, this is kind of goes back to our mathematical background here, and I've showed some of these off. But a Boolean is basically a true or false value. And it uses some of those comparison operators that I showed earlier. So 1 equals 1 is true. Let's go ahead and store that in a value here. And then we can see what the type is of that. So you can see bool, which means Boolean. Let's just go through some of these operators. So you can have a not equals. So, and again, I showed off some of these with the mathematical stuff. Less than, greater than. Let's see, what else do we have here? I guess we could do this too. So with Python, unlike other languages, you have to make sure you capitalize that first letter. So if you have capital T, R, U, E, it knows that that's a Boolean true. So if we do, so that's a reserved word in Python, is true. and false. In other languages, a lot of times you'll just see it with lowercase. You can see we get an error there. So you got to make sure you capitalize in Python.
Why is beginning to put 1 equal 1?
So the result of that operator is a Boolean. So, but you can also use true and false too. So, and we're going to actually get into some logic here, where we're actually use some of these. But the equals equals is an operator, so that's saying, is 1 equal to 1? That's true. Let's see if we have any. I think I have some. Okay. Yeah. So let's go into some more advanced Booleans. So a lot of times we want to combine things. So when we get into logic, into some of the logic flow, we want to combine things. So we have what's called an AND expression. Oops, I just exited it by accident. All right. So if we want to say 1 equals 1, and I want to know if 2 equals 2, we can combine those. And the result is a combination. Are both of these true? We also have an OR statement. So let's try that out. So if you use OR, it's saying, is any of these true? So now if I change this, the first statement is true. The second statement is false. But I used the OR expression. So OR means, are any of these true? And the answer is yes. One of them is true. You can kind of optimize some of your programs this way. So it's always going to do the first one first and the second one second. So sometimes when you want to optimize things, whatever's more important, if you put it first, that's going to execute first, and then whatever's second. So it actually, when it goes through and executes this, it sees, oh, 1 equals 1, that's true. I don't even care about the rest. Just return true. So when you go through some of your programs, if you want to ever optimize things, the OR is actually kind of a good way to like go through and say, do this first, and if it works, skip the rest of it. So now if I were to do this, it's getting false for the first one, and then it goes on to the next one and says, is that true? Okay, return that. Okay, so we have our OR. Another expression that we have is not. So not will give you the opposite of what the answer is. So we could say 1 equals 2, right, is false. But we could say not that. So now that gives us the opposite, so that's true. And when we go into some of the control logic, that will kind of make more sense. But not can be very confusing if you're combining it with things. So you got to make sure you, if you're doing not this, not that, it can get complex. So you definitely got to watch yourself when using not. Yes, so we can also use explanation point. So that's saying 1 does not equal 2. Now, how you know to use the two is sometimes the mathematical operator makes sense, and sometimes it doesn't. So, like if I were to do this, this is going to error out. It doesn't know what to do with that. So since I'm comparing two numbers, I can use the mathematical operator.
Can you do that, like with the or statement, like 1 equals 2, or 2 not 2 equals 2?
Yeah, I mean, I could put a not in front of this. Yeah. Now, like I said, that is actually really confusing, right? So even if you're like an advanced Python user, you got to watch out. You know, it's better to make stuff readable, right? So even if you're like an advanced guy, that's really confusing. You probably don't want to do that. You know, so it'd probably be easier for someone to read if you did it this way. That's up to you. But yeah, try to make stuff as readable as possible because it's easier to write a program than it is to read it. So someone's going to come back and be like, why did this guy write this that way? So yeah, here's some examples. We can do this with strings, right? So we can say, does apple equal banana? No, it doesn't. But does apple equal apple? Yes, it does. I showed, you know, you can just do it this way too. So we can use true and false. So this is saying is true, true, and false, true? No, it's not. Again, we can make these really complex. It follows back to your order of operations days in math. It follows the order of operations. So if you start making complex things like this, you know, maybe you should throw in the parentheses. Again, that's up to you to make your code readable. And that's just some. So the in, and I showed this before. So let's see. Let's go back to our list here. The in is another Boolean word. Oh, we had fruits. I thought I had fruits. Oh. All right. So let's define our fruits again. We had an apple. We had a banana. I don't know. Here's my favorite new fruit I found out about last week, a pawpaw fruit. All right. So an in is another expression that we can use that will generate a Boolean answer. So we can say, is apple in our list of fruits? Yes, it is. Is cherry in our list of fruits? No, it's not. We can combine this now with not. So is cherry not in fruits? Yes, that's correct. That's not in there. Now, same thing like we showed our dictionary. So let's create a dictionary again here. I have 4 cats this time and 2 dogs. So let's see. Do I have any cats? Yes. So with a dictionary, it's just looking for that key. Is that key in that dictionary? Yes, it is. Do I have any lizards? No, I don't have any lizards. And again, we can combine that. So, yes, I don't have any lizards. Lizards are not in pets. And my output is that Boolean. All right, so is there any questions on that? Do the what? So like say, does that have that value? There is a method for that. I can't remember what it is off the top of my head, but yes, there is a method where you could say, is that value in the dictionary? That's less efficient. So dictionaries are actually really efficient. So if you are looking stuff up by value, you probably want to reverse your keys and make your values your keys and make it opposite. But yeah, you can say, is that value? I can't remember the last time I've ever used that, so, but yes, you can. So your keys, no. Your keys can actually be anything. So we could flip this on its head. Let's flip this on its head. Like the question we just had. And make the keys the values. So now, if I look this up, yeah, lizards isn't in there. But remember, it's looking through the keys. So it's saying cats are in there, but yeah, the number 4 is in there. So your keys can actually be anything you want. It can be an integer, it could be a string, it could be another object. However, I would say like 80% of the time, you use a string as your lookup. That's normally what you're doing. So, and when you use complex keys, you have to watch out because what you're doing with that, it can get confusing really fast. You had a question? So like this. So this is going to give us an error because there's nothing there. Just like that. Yeah, so we could have just that in there.
No, he was just saying, can you flip your keys in your string? Where you have come first.
Oh, yeah. Yeah, I mean, we could... Remember, for a dictionary, order doesn't matter.
No. The order, the string being dogs.
Oh, can you mix them? So what you're saying is, can you mix them? Yeah. Yeah, you can mix. Your keys can be whatever you want. Yeah, so you can do that. I would not recommend it, but yeah. Yeah. Like I said, normally you're just looking stuff up by a string. You just want a key value, and you want to... Dictionaries are good for like a really fast lookup. You want to store some data and then look it up really fast. So like we could make a list, and we could say okay, I'm making a list, and I'm going to document this, and the first value is always going to be cats, the second value is always going to be dogs. And you could say, everyone follow that standard. With the dictionary, it makes it really explicit. Someone sees your code, I know what's happening. I don't have to write any documentation. I know cats, and I can look it up really fast. No, like I said, it actually can be an object of it. Yeah, you could, but you got to be really careful, because especially when you make your own types, if you don't, like, are two lists equal? So it can get hairy. Yeah, so there's what's called a magic method that you can create on objects that tells it how to handle the equals equals when you make your own types up. So you got to make sure you do that. And that's not going to be there by default, all that magic, cool stuff that's happening right now in the background. So, You got to be careful with it. But yeah, it's very possible anything can be your key. All right, so any other questions on that? On dictionaries? They're actually really cool. You'll use them a lot. And like I had mentioned before, any of these types, you can take them and extend them and add some of your own logic. Like ordered dictionary is actually already written, but you could go write something like an ordered dictionary if you really wanted to. All right, so let's talk about some logic and how we control how things run in our programs. So, and this ties in really close to Booleans. So let's go over if statements. All right, so now, first thing before we kind of get into this, Python, the way it's organized is you have to use white space. So there's no open close brackets for different blocks of code. It's all controlled by white space. So when we type this into the interactive terminal, you're going to see ... Anytime you see that, it means it's looking for some white space, and that's going to tell it what to do on the next line. All right, so let's try an if statement out here. So we're going to do my name is Paul. And we're going to say if my name is Paul. So with the if statement, you have the if word as your first word. You have your Boolean expression, and then you have a colon. So the colon is going to tell Python this is a block of code. So now when you have that colon, you can see I get the ... Now if I were to just type I'm going to get an error. Because when I type that colon, it's expecting a block of code. So I need to put some spaces in that. So I'm just going to use 2 spaces. But the Python standard is to indent stuff 4 spaces. So when you're writing your code, you'll see a lot of 4-space stuff. I actually like using 2 spaces. So if you want to hear my whole argument on that, I have a talk about that tomorrow. But I'm just going to use 2 spaces in this for... I guess you really could use 1 if you wanted to. You can use tabs if you want to. You can actually even mix them. A block has to use the same... So one block has to use the same indentation, but different blocks in the same file could actually have different indentations. That is definitely not recommended to mix stuff because you'll confuse the heck out of the next engineer if there's tabs and spaces everywhere. And actually, Python 3 enforces the indentation more than Python 2. So Python 3 won't let you mix tabs and spaces in the same indentation. So yeah, just pick one and use it. So let's go back to our if statement here. All right, so this is my block of code. I indented it. So I hit enter. I'm still not out of that block of code yet. You can see I still get the ... Now in the interactive terminal, if I want to end that block of code, I just hit enter again. Now it's actually going to run that block of code. So let's go through this. It's saying, if my name is Paul, go do the stuff that's in this block of code. And so I'm printing my name, saying, hello, Paul. So that's the if statement. That's a basic if statement. All right, so let's get a little bit more complex. So a lot of times you want to say, if this is true, go do this. But if it's not true, I need to go do something else. So let's start with, if my name is Paul, print hello. And then the next thing we're going to do is else. So else is the way you do something else if that first part isn't true. So again, I'm going to indent 2 spaces or whatever you're using for your indentation. Let's say, I don't know who you are. All right, so right now I have name is set to Paul, so I'm still getting the first piece of that. But let's go ahead and change our name up here. Now we're going to have to retype this in. Again, you can use arrows to get your old commands. Use the up arrow. All right, so now this time name is equal to Jess. I should get that second block of code instead of that first block of code. All right, so that's the else statement. Any questions on if else so far? All right, we're going to kick it up one more notch. So now let's say you wanted to do mix. Right now we can do 2 different things based on that Boolean statement. Let's say we wanted to do 3, 4, 5, 6 different things. We can now chain this even more with more Boolean statements by using else if. So in Python, they shorten that to elif, E-L-I-F. So let's try this some more. All right, so let's start with our first line. And all right, so now let's do another Boolean though with else if. So if our name equals Jess, let's print you're awesome. But if we don't know who it is, again, we'll say, I don't know you. All right? All right, so right now, our name is equal to Jess. It says, okay, I don't match that first Boolean. Go to the next one. I match that one. So I'm going to run this block of code now that says, you're awesome. Again, we can change that up. Put in Chris's name so he pays attention. No, he's still not going to pay attention. Retype in all of our stuff here. Okay. And it doesn't know who Chris is, so it goes to that last block and hits it. So basically, this is a way for us to do some checks and then run some code based on, whatever logic we have programmed into there. Any questions on that? Okay. And we've kind of went through this, so we'll just go on here. All right. So another way we can kind of control the flow of our program is to have a loop. So this is where the lists and dictionaries in Python are really powerful, because a lot of times we have a list of things and we want to go through that list of things and do something to everything on that list. Another use case is that we want to count, maybe we want to do something 10 times. So we want to keep on doing things. So we can do count. There's also loops, conditional loops. So we say, keep on doing this thing until this is true. So we'll go through some different ways that we can do loops. All right, so this is going to count. We're going to do an example of this would be like, okay, you want to count every jelly bean in a jelly bean jar. A conditional loop might be, an example of that would be, you have people signed up on your mailing list. And if they're subscribed, or if you've already sent one to a subscriber, then stop doing it, or go through your list and stop doing it. So let's do a counting example. So there's basically two ways of going through or doing loops in Python. One is the for statement. The other one is the while statement. So we'll do the while in a second. So let me type this out here. The for statement, and again, it uses the in keyword. So what this says is for every number in this list, keep on doing whatever's in my block of code. So again, we use a colon. And we indent. And now we can do something in that block. And let's use string formatting this time. All right, and when we're done with that block, you just hit enter again. So we can see what happened is we went through each of these things and did what was in that block of code. Any questions on that? So what's your question? Oh, that's just the string formatting. So another way we could do that is we could have done it this way too. So that's another way we could have done it. Oh, we can't convert. Let's do it this way then. Oh. So let's do it this way. All right, there we go. So I was just showing string formatting there. So there's actually several ways you could do that piece of it. So all that is, again, it's just for every number in this list, do this block of code. Now, let's go back to strings, right? So what were strings? Strings were characters that are just put together. So the for loop is actually pretty smart. And it knows if that object is iterable, it knows what to do with it. So let's say well, actually, let's just do it this way. We'll say for letter in hello. And we'll say the letter so it knows that a string is just a list of characters, and it knows how to loop through that. So basically, anything that we've done before where you can pull things out with like an index, we can now loop through it. We can loop through a list. We can loop through a string. I guess we could, let's do this. Let's loop through a dictionary. Do I still have my pets? All right, let's put my pets back in a dictionary. All right, so I have 4 cats and 2 dogs, let's say. So let's say for pet in pets. All right, now the dictionary is going to act a little different though. So let's just print out what it gives us so we see what happens. So when it loops through the dictionary, it's basically looping through the keys. So it's saying cats, dogs, whatever, right? Let's do that loop again. So now let's say we want it to print out not only the key, but the value. So now we're looping through our dictionary, and we're saying, that's the key, that's the value. That's the key, that's the value. Actually, let's try this again to see if the order is maintained. So it looks like it probably will come out since this is a really simple dictionary. But again, remember, with a dictionary, your order is not guaranteed. If we do the list example, if you go back to the list example, that list is always going to come out in that order. So just keep that in the back of your head. The list is always going to be in that order. All right, so let's go to the next type of loop. The second type of loop, any questions on the for loop before we go on to the while loop? Okay, so the next type of loop is what's called a conditional loop, and that's used with the while keyword. So let's clear this out. So with this loop, all right, so let's make a count. We're going to start our count at 0. And we're going to say while count is less than 5. All right, so that's a condition. So this loop will run until the count. Actually, I should do that the opposite because it's not. Let's say it's going to run until the count is greater than 5. Now, let's produce an error here. Now, I'm not doing anything with this count. Oh, hold on. I was right the first time. I got that backwards. So we can see now, I'm not doing anything to the count variable. So I'm stuck in an infinite loop right now because count is always less than 5. So let's do something. If I can, hopefully I didn't crash my system, which I think I did. I'm stuck. So this is the common problem you'll see is you'll make up one of these conditional loops and you don't have good logic, and so you get stuck in an infinite loop. All right, I think I'm stuck here. This totally just killed my. Okay, I guess we're going to have to refresh here. That totally killed me. All right, so let's hide this. Let's do a new terminal. All right. All right, so let's do some logic that actually works and doesn't get it stuck in an infinite loop. All right, so while count is less than 5, and then let's actually count. So let's print the count. And then let's change the count this time so that we don't get stuck in an infinite loop. All right, so every time this loops, I'm going to add 1 to the count. All right, let's see what happens this time. Okay, yay, we didn't get stuck in an infinite loop. So this time, every time that block of code run, the count got incremented by 1. It checks the condition again, and it keeps on running until that condition is not met anymore. Yeah, so there is a shorthand. Okay, let's reset our count. This is one of the operators I didn't show. So let's print our count. There's actually a shorthand for that notation, the plus equals operator, that it will increment it by the value that I give it, which is 1. So that's a plus equals is another operator you can use. And that operator works on lists too, so and multiple data types. So that's the while loop. That keeps on looping until that condition is no longer met. All right, so any questions on the while loop? Let's go into, I guess, a little bit more control flow. Now, this is dangerous territory. So you don't want to do this a lot, but sometimes you do need it. So this right here is dangerous. While true. That means this is going to be an infinite loop. But there's actually a control word. Well, let me do a print statement first. Print hello. There's actually a control word that you can use that says break out of the loop early, and that's break. So while I basically, with that first statement, hard-coded an infinite loop, the break statement gets me out of it. So this is useful sometimes where you don't necessarily know or you're waiting for something. So maybe you are checking like a website for, like my kid wants a Splatoon figure or amiibo. You know, maybe I write a Python program that checks that website to see if it's in stock. And I want that to loop and loop and loop and loop and loop and keep on checking until it actually finds it. And then when it finds it, it does a break. So I don't know when that is going to happen. So I do want an infinite loop. And I want it to break out when it finally finds it. So, like I said, you don't always, this is, can be dangerous, but it is useful sometimes. And you can use break in the for loop also. So let's do that in our for loop. So we have our list of things. And let's print a number. And let's use an if statement. So we'll make this a little bit more complex. All right, so if the number equals 2, now I have to indent twice because I'm in a block of code, and then I did an if statement. So I'm in another block of code now, so I have to make sure you indent twice now. You usually have the colon inside the colon. So now I'm saying if the number equals 2, break out of this loop early. So now instead of going through the whole loop, it can break out. This is probably a better use case that you'll probably use more often, is that you want to loop through something, but if a condition is met and you're just finished and you know you're finished, break out early. All right, so any questions on while or break?
Is there a way to show a span of numbers that I can always
Yeah, so I can show that. So that's actually a quicker way of counting. So I showed that count example. Really a faster way of counting if you're just going to count. There's a range, built-in range function. And actually, there's a really great amount of built-in functions. I'm going to, later on in the tutorial, I'm going to show you where those are. Range is one of these built-in functions. There's so many, there's like no way, even if you took like a whole semester of Python, that you'd probably cover all of them. But I'll show you where they're all documented. So range just does a count. So let's do number. And I guess for completeness here, let's go ahead and show the last kind of control word in a loop. So let's go ahead and do our range. So another thing you can do, let's say if number equals 2, another control word is continue. All right, so let's see what this does. So if you look at our output here, what continue says is, hey, I still want to do the rest of this loop, but I kind of just want to skip this one. So if you look at the output, it goes 0, 1, 3. So when we got to 2, it just skipped it, but continued doing the rest of the loop. So sometimes you don't necessarily want to break out of the loop. You just maybe want to skip some of them. So that's what the continue keyword will give you. All right, any questions on that? All right, so I have another examples of, just go ahead and try these. I'm going to just go ahead and end, I guess, this half of it because, so we'll go up to lunch. So here's some exercises you can try. And let's just say we'll meet back at lunch because the next half of this now is going to go into some of the more advanced stuff. So yeah, work on lists if you want to try out some of these examples. Lunch is going to be at noon, so we have an hour break for lunch. So we got about 20 minutes till lunch. Yeah, try out some of the examples, and then me and Chris will be around if you have any questions on loop or list or dictionaries, if you want to play around with them. All right, so I'll see you after lunch. Any questions in general on anything, though? So I guess I will go ahead and show you that here. Let's go to the docs here. And I'll have these linked. I guess let me just do a Google search for it. So this was what I was talking about. These are the built-in functions. There's also modules, which we'll get into the second half. You can see there's range. Let me make this a little bigger. So here we go. Here's print. So here's the options that you can specify. These are the default. So you can see the default separator, the default line ending. You You can actually even send your output to something other than the screen. So sys.standardout means send it to the screen. And then you can also tell it how often you want to flush. So let's try some of that out. So like you asked about the line ending. I'm going to say, hey, I don't want a line ending. I don't want a new line. You can see that kind of screwed up our interactive prompt now because there's no new line. Let's try that again. Now we have a new line at the end. You could go crazy, right? So everything now is going to have that line ending. I guess maybe a more useful one, maybe you might use more often, is the separator. So if you want to change that separator, so if you have multiple things, so now instead of a space, it's going to put a dash in between everything. I don't know, maybe like, I like putting colons when I'm like logging stuff. So that's how you change the separator. And then so if you did turn off so normally, right, you get a new line every time you print. So we turned that off. Let's do a loop. Loop is a good example of that. So we're going to print a number, and then, but we want the line. We don't want any line ending. Or actually, let's make the line ending a comma. So we want to list all of our numbers, and then we don't want to print the line ending. So /n is your line ending till the end. So you could list out all your numbers in one single line, and then print your line ending after it went for that list. So that's probably a good example of where you would not want to use a new line after everything. What was the question? Any other question on that? I guess another cool one might be, so /t is your tab character. Put a tab in between everything. There's a lot of tab delimited data out there. Or comma delimited CSV file. If you're on to any of the machine learning kind of data talks that we have here, a lot of that data is in comma-separated files. So maybe you'll have to output to a comma-separated file. There's actually a comma-separated module just for that, but this would be a quick way to do it. Any other questions? All right, so when we get back from lunch, we'll do functions and input, modules, classes, objects. So that's some of the stuff you can look forward to after lunch. Like I said, I'm here. If you want to practice some of this stuff, I'll answer your questions now, and then lunch is at noon.